For centuries, humanity believed we had conquered the global commons. We built ships the size of skyscrapers. We forged them from high-tensile steel, powered them with nuclear and diesel engines capable of shattering ice sheets, and guided them using a constellation of satellites orbiting miles above our heads. We convinced ourselves that the ocean was merely a highway, a predictable blueprint of trade routes. But this is a dangerous illusion. In the deep ocean, far beyond the reach of coastal radars, the rules of civilization cease to exist. Out here, water is not a liquid. It is a kinetic weapon. When the atmospheric pressure collapses, the ocean transforms into a chaotic thermodynamic engine, capable of generating forces that defy standard physics. In the next 25 minutes, we will look past the spectacular footage of ships tossing in the waves. We will dissect the raw physics, the structural engineering, and the terrifying reality of what happens when man-made giants encounter the true, unbridled ferocity of the open sea. This is the anatomy of a maritime nightmare. To understand the terror of an ocean storm, one must first understand the concept of fetch. Fetch is the horizontal distance over which a constant wind blows without hitting an obstruction. In places like the North Atlantic or the notorious Drake Passage, the fetch can extend for thousands of miles. There are no islands, no land masses, nothing to break the wind. When a severe low-pressure system, a process meteorologists call explosive cyclogenesis, drops 24 millibars in less than 24 hours, it acts like a giant vacuum cleaner in the sky. The winds screaming around this vacuum transfer their kinetic energy directly into the water. It starts as a ripple, then a wave. But as the wind continues to batter the water over a massive fetch, those waves stack. They inherit billions of joules of kinetic energy. They don't just grow taller, they grow wider, faster, and infinitely heavier. 1 cubic meter of seawater weighs exactly 1 metric ton. When a ship is struck by a 30-meter wave, it is not being hit by water. It is being hit by a moving wall of concrete, weighing hundreds of thousands of tons. For decades, marine engineers designed ships based on standard linear wave models. These models predicted that ocean waves followed a predictable Gaussian distribution. According to old maritime textbooks, a wave exceeding 30 meters in height was a statistical impossibility, something that should only happen once every 10,000 years. Mariners who claimed to see walls of water rising out of a storm with near vertical cliffs were dismissed as superstitious. That changed on January 1st, 1995, at the Dropner oil platform in the North Sea. A laser bridge sensor recorded a single, solitary wave that shattered all mathematical paradigms. It was 26 meters high, surrounded by 12-meter waves. It was a rogue wave. Rogue waves are not caused by earthquakes or tsunamis. They are born from non-linear physics. Through a phenomenon known as constructive interference, multiple wave trains traveling at slightly different speeds and angles collide. Instead of passing through each other, they steal energy from one another. The smaller waves feed the larger one, focusing an immense amount of power into a single, terrifying peak. For the captain at sea, a rogue wave gives no warning. It appears on radar as a glitch, presenting itself as a vertical wall of black water, receding into an unnatural trough. The ship falls into the water, then the sky collapses. When a ship encounters waves of this magnitude, it enters a lethal game of structural mechanics. The human mind struggles to comprehend the flexibility of a modern commercial hull. A container ship or a supertanker is not rigid. It is designed to bend, twist, and flex like a massive steel spine. But every material has a breaking point. As the ship crests a massive wave, it faces the danger of hugging. This occurs when the bow and the stern are empty air. The hull compresses violently. If the frequency of the waves matches the natural structural frequency of the ship, a phenomenon called parametric rolling begins. The ship starts to rock uncontrollably from side to side, executing 30-degree rolls in a matter of seconds. Containers snap their steel lashings, plunging into the abyss. If the engine fails, the ship loses steering. It falls into the trough, turning broadside to the waves. At that exact moment, survival is no longer a matter of human skill. It is entirely up to the weld lines and the quality of the steel.